In this video, we are given that f of x equals sine x plus cosine x all over sine x minus cosine x. We want to find y such that f prime evaluated at x equals y equals -1. So f prime of x will be the derivative with respect to x of sine x plus cosine x all over sine x minus cosine x. So now we're going to use the quotient rule. So this will be the denominator. So that will be sine x minus cosine x times the derivative of the numerator, which is cosine x. The derivative of sine x is cosine x. The derivative of cosine x is minus sine x. And now we're going to have minus the numerator, which is just going to make more room. So that will be sine x plus cosine x. The derivative of the numerator will be cosine x minus derivative of cosine x is minus sine x. So this will be cosine x plus sine x times sine x plus cosine x, which is just sine x plus cosine x quantity squared. And now it'll be all over the denominator squared. Okay, but we can write this cosine x minus sine x as -1 times this term, which is sine x minus cosine x. So we're going to factor out -1 sine x minus cosine x quantity squared all over. So we're going to have sine x minus cosine x quantity squared. So we're going to split the fraction. So we have minus parentheses sine x plus cosine x quantity squared over sine x minus cosine x quantity squared. So that would be f prime of x. But we can cancel out top and bottom, leaving us with -1 minus parentheses sine x plus cosine x squared over sine x minus cosine x squared. So now we also know that f prime of y equals -1. So we're going to plug in y to the function, and we're going to set it equal to -1. So we're going to have -1 minus parentheses sine y plus cosine y quantity squared over sine y minus cosine y quantity squared. We're going to set it equal to -1 because f prime of y is here and -1 is on the other side. So now we're going to add 1 on both sides because we have a -1 on the left hand side. So when we add 1, this will cancel and the right hand side will equal 0. And then the negative can cancel because -1 times 0 is still -1. So when is a fraction ever equal to 0? That's when the top is equal to 0. So a over b equals 0 when a equals 0. Now b can't be 0 because 0 over 0 is undefined. So we'll just set a equals 0. So we have sine y plus cosine y quantity squared equals 0. But when you square root of 0, square root of 0 is just 0. So we can just set the inside equal to 0, leaving us with sine y plus cosine y equals 0. So let's divide by cosine y, leaving us with sine y divided by cosine y is tangent y. Cosine y divided by itself is 1 equals 0. So tangent y equals -1. And also cosine y can't be 0 in this case, so we can check that at the end. So when is y? So how do we find y? So tangent of pi over 4 is 1, and tangent is an odd function, so we can just say that y equals minus pi over 4 because tangent of pi over 4 equals 1, and it's an odd function, so when you take the negative, it will go to the outside. So y equals minus pi over 4. So we can just check that also doesn't. So let's say sine pi over 4, negative pi over 4, minus cosine of minus pi over 4. Let's see what this is equal to. So sine of pi over 4, sine of negative pi over 4 is negative square root of 2 over 2 minus cosine of the same thing. But cosine of negative pi over 4, because it's an even function, it's the same thing as cosine of pi over 4, which is square root of 2 over 2. And you're subtracting these, so this is negative square root of 2, but that's not equal to 0. So this is the answer, and that's the end of the video.